Hi, I would like to present to you a little project I'm creating. It's for a distributed audit system. It's and I want to share to you the concept, but expect to be incomplete because it is on a developer preview, so have some bugs and is not current use, but is usable because I'm using on a product system, so you can try on your own. And I will try to make a short video, but I can't promise that for you. And the goals, let's start with overview of the system. The goals of the system is to be distributed, and that means that the parts of the system are not coupled with each other. You can change the parts and scale the parts independently, and it tries to be scalable. So if you are centralizing the audit of events and you have maybe you could have millions of events per day, and depending of the number of applications you are auditing and the volume they generate, but it tries to be scalable from the start. So it's need to be secured, and by secured, all the parts of the system need to have a minimum of security on it, and you try to be robust in the sense that it needs to be it needs to be adapted to different use case. So an overview of the system is we have four main components and have five main components, but none of them it's required to be the ones I am developing. You could change for wherever you can change that easily. So first goal is that it's any type of applications. If you see on the right, you can use a Java application. You can audit in any language. You can audit on C# or PHP, and it doesn't matter what and how is the application being built. You need to be able to generate the events and collect them. But generate the events is not an easy task. It's a simple task, but not an easy one. The best way to do that is using aspect-oriented programming, and some frameworks has support for that. So the project is currently been using a lot Java and Spring framework. So I'm creating an audit app client that is a component to help developers to generate that events. And the events are generated and put on the RabbitMQ component system. Again, could be any other component, any other quiz system you use. And the event is saved on JSON. It's generated on JSON and published on the quiz on the JSON format. And the audit MQ collector, its only job is to get things on the query and save it on the permanent storage. Case is PostgreSQL, but you can change the collector to save on any kind of database, or you can expand the audit MQ collector to save on any kind of database. So you can use an NoSQL or wherever you want here. And the audit view is just a simple web application to see the events generated saved on the PostgreSQL. And you can use the SQL, the SQL client of Postgre to have a more control on what you are filtering. But Audit View offers a nice way to people that are not on the tech start to see the events that are generated, save it, and hopefully get some insights on it, some reports on it. So I say that the component is loosely coupled, so you can change everything. You don't need any of the components to do that. So I have a components that is the model for the object that will be saved on the query. It's not required, but used in the collector and view and app client. Just a standard classes, just a standard object to be published. And the collector, as I say, its only responsibility is to collect the events from the query and save in the permanent storage. So I'm going to show you a demo of the collector. So I'm going to show you some code for the collector. Not show you everything. The main object for the collector is to process the event and send a message. So as the message gets in the query, he will save on the database, and if any exception is thrown, he will publish an event for that exception, and the event will try to reconnect to the database and save it again, so you don't lose the event. The event is going to be on the query, and if the exception is thrown, it's going to remain the query, and the collector will try again later. If we try again in a max of 3 shots of 10, it will wait for 30 seconds and try again. And let's show you how the collector works. I started the collector, and let's see if my database is up. I'm gonna delete, I would delete and all the events. I'm gonna show you how to generate them. I create a project to test the events, and the query it's running on the local host. Actually, I have the configuration here for the dev environment, and the RabbitMQ query is on the Docker local. So I have a Docker running the query. You can run the query, RabbitMQ query, using the Docker command, and I have a documentation for that I'm writing. So you can run that comment, and the RabbitMQ query will be available for you in the Docker environment. And the tester is configured to run and send a message to the query. So it will send a message and exit, and we see a message on the database. So the audit tester, let me show you the code for that. So the audit tester just create audit event and send it as a JSON object to the queue. The JSON object, it's a standard object, and the audit event has these properties. So if you see that we have an action, the ID is not, you should not put that here. So the ID is generated by the database. So we have the action that was made by the user. We have the application name, this is the application that is being audited. And we have the user. So the user action was application run. You can think of that as a standard action string. So you should standardize it across your application. For instance, I have in this object, I have in the model, I have show you here. The model has, by instance, some standard actions. So for database action, it has insert, update, delete, select, insert, or update. And each action has a prefix, and the prefix for this is database. And so it's going to be database underline select, database underline delete, and so on. The LDAP action has a prefix of LDAP, and you can create, read, update, delete, move, change the password, enable, disable search, so that the user can be enable, disable, login, logout. So that's the actions, examples of actions that applications can make, and you should generate your own. And the resource for the event is the thing that actually is the subject of the action. So that type of resource could be a user, or it could be a client. So if you have a create client event, so the action should be a database create, and the subject should be, resource type should be client, and the resource ID is the ID of the client that was being created, or the ID of the resource that was being applied the action. So this is a cool abstraction, and I think it can serve for many user cases. But when currently you cannot change that, you cannot save your own events, but it's my goal to provide a JSON storage, so you can generate wherever thing you want on the event. But you should standardize the events. And security level is just wanting to show if it's a normal operations, is a high security operation, or is a sensitive operation, something. So just do that. The IP address is the IP address of the user who made the action on that date. So it's a complete event to track who does what. One thing cool about the audit log is that the audit collector can provide some interesting things, like can recover for failures, like gonna stop PostgreSQL. Yes, and I'm gonna generate another event. So the event is still send it to the queue. Don't fail. I don't think the database is down. It's not down. Now the database is down and the collector detects that, and when it tries to save, it will try 10 times before it is stopped for 30 seconds and start all again. So it's the third time, and you can do interesting things here. We can send an email to the IT department so they can fix that, and the queue but event it's there. The event is on the queue. I'm gonna send another one to the queue. So if I recover for the failure, and in 13 seconds it will collect the things again and save on the database. So we don't have done yet. We have 104 ID 101, 102, 103, 104. Send another one. $105, so it's already up and we don't lose any event. Well, the client needs to take care when the message queue is out. So it's user code, you should do that, but if you use the queue, the app client library that will provide it, this library will take care of that. So if the queue is not on, is not up, you can assure that it will save local and then try again later. So you don't lose any event even if the system is distributed. And the view is a nice user interface for event logs. And let me show it that in action. The audit event view, it's an Angular application. It will connect to the data to the PostgreSQL database and run and show the logs. But there's one thing interesting in the audit view, and it used the keycloak server for its authentication. So you have a central user authentication, and that's the idea. So if you the same set of users that generate the events, it's used on all applications that are audited. That's the goal. And some of them may have access to the audit view with the same user and password, and you can delegate things across the entire enterprise. So to run that, I will need to run a keycloak server, because otherwise I cannot log in. So I'm gonna to run keycloak with that command. And I will configure the application to authenticate on the keycloak. It's in that file. And I will create a username and password for that. So don't worry about that, just to not use the same realm. Well, you don't need that. Let's use the master realm. So I'm gonna create a user that is just admin user. We'll add one user, save that. The credentials, you need to change the password. That's one cool thing about the keycloak server. It has a lot of user filters. The user can reset its password. The user you can use LDAP to authenticate. You can use Facebook to authenticate. A lot of features for this great project. So I'm going to create a rule for the application, otherwise the user will not have access to them. So let's try that. First I'm going to create a client configuration. The client configuration is to have a valid redirect URL. It needs to be the server of the audit view and /SSO/login. So I'm going to install the security keys on the file. So let's run that. So the query is also configured to go to the database. It's already configured that. So let's try it out. If I try to log in, it will say that I am forbidden because I am the admin user and I do not have that rule required for the application. And it's documented here that the documentation needs audit view access permission. So we're gonna add a new rule for that. Gonna save and gonna add the user to that rule. View access. Now I'm gonna use another browser to log in. With the user, my user needs to change its password. Now I'm authorized to see the application. Let's see what happens if I don't have the access. Should user 34, yes, forbidden. So I need to log in again. With the audit view access. So the audit view, we can see the events. The events here. So you can search for them by action, application, run, and by IP address and date time. So that's it for Audit. And the API clients library are abstraction for the development of the systems to be audited. And I don't have a demo for that, but I can show you some code. And let's see what can be done with that. So open new window. The app client Spring is application with some aspects for them, and is a library with some aspects, define a point code. And the best way to show you that is to show you the test. So I have test all the special. Let me see. Target. So I have a annotation here in the class audit table. It's a Spring component, and that so I have the annotation on the class, so all methods should be audited. So this first method will be the name of the method, it will be the action. And the second method, I am overriding the action, changing that, and then overriding the security level to hide, and the security level in that case is normal. And on the second, I have an audit table here, but I have a no audit component here that can annotation here that can be used on the class or on the method. So in this case, this class will be audited, but this method will not. Only this. And that's just a fake. Just a fake one. And let's see the test. The test, we see if the annotations, if the aspects are correctly running. So let's run them. All tests are running and green. That's great. I do not have this API can change in the future, and it do not do nothing. It does nothing. Let me see. Oh, actually, it's dispatching the events, and you can dispatch the event manually as well. And let's summarize that. You should centralize your audit event, and it have a lot of benefits, like the development effort is shortened, and you have more efficiency on the way you perform the audit and process, because you can search in a central place for all events that happen on your applications. And you should provide a single sign-on for your apps and a unique user base, and that can be done very easily with Kcode Server, and you should check it out. It's open source, and they have an enterprise offer as well. It's a Red Hat project. It's well banked. You should enable strong security across all enterprise. And if you have a central audit event and a central single sign-on, and the next step, the natural step, is that you can enable a strong security policy, and you can, for instance, let users use two-factor authentication, and that can make the security of your entire enterprise way better. You should take a strategy. Advantage of that and enable cross-application event decisions. Well, if you have all the audit logs on your centralized repository, you can do smart things. Like, use case you could have for that is a user perform an action on one application, and that application crashes, and the user then open your service desk and open and send a crash report, and the next time the user perform that action, you can have a supervisor automatically checking for if the problem persists for the user, and that is based on audit event logs, and you can do that in real time and send feedback for the user. So, oh, I see you don't have that problem anymore. So let you know that I'm here to help you again if you have something like that. So you can enable cross application decisions based on these events and on these actions. You can be proactive on them. So the person is unique, why not the user? So if you treat the user as unique and you don't have a lot of passwords for them to remember, you are making the life of the user better, and you are making the security better as well. And what about server access? Do you remember Sony case when they find all passwords in one file on the network? So that's because the person is unique, but it has hundreds of passwords, dozens of passwords. People are not meant to remember that. Don't overestimate external cloud or third-party systems. Connect them to your authentication when available. Well, if you use a single sign-on, you can connect the things to you. You can connect to the parts to your authentication, and maybe you can connect the event system as well. You will need your third part system to have some things that made you, but you can collect them and send to the event system. And I'm sure you can collect the events and send to the system as well. And most importantly, people are the key part of the security system. Don't treat them as machines. They will not remember all these passwords. And that's what I think. Thank you.